Alright, we'll come back to that one. So anyone playing along at home, we're talking about circles today. We're doing the Desmos activity, rolling along. And let's look at some of your guys' comments on what would have been helpful. So on slide 4, which we're all either on or past at this point, what would have been helpful to know when we're looking at these, right? The bigger blue, littler blue, and then blue versus red. And people said, how long does it take to make a full rotation? How far can it go in a full rotation? That is easier to tell you where you get inside, show where the halfway point is. Well, yeah, if I know where halfway is, I could probably find the whole way point. How fast are the circles moving? I don't know if speed matters, if it's just a rotation, right? Like, if it goes more than one rotation, that would matter. But speed of how quickly it spins, I don't know if it matters how fast it spins. How big the circle is and how tall it is.
It shows us.
Well, on the next slide, it shows you. On this slide, all you had was this, right? On this slide, all we had was kind of the size of the circles. A point on the other side, how long the circle is, how long the circle is stretched out. It matters how big the circle is. The ooh, mathy word right here. Circumference. We'll work on spelling, but that's okay. What's a full rotation? A full rotation is a circumference. So then we come here. And we have a 2 circle and a 3 circle, right? We got a 2 circle and a 3 circle. And when I hit play, I end up slightly past 6 and slightly past 9. So then if I look at what you guys said based off of this, I notice the bigger shape travels farther than the smaller. I wonder if size impacts the outcome. Yeah, that's a good wonder. It added 3. I feel like they typed added, but they meant a different word. It would be exact if I go to decimals. Yeah, that number line did not show us decimals, right? Notice that it goes slightly past 3 times its original length, right? That dot is 3 times. So somebody else said added 3, and now somebody has said 3 times. Circle went almost triple the number above. The bigger one goes further, yeah. And I know some of you are still typing this, and I had paused you in the middle of it. Wonder if changing the size will make it go, I don't think you mean faster, I think you mean farther. Right, and farther is kind of a weird word, because is it further or farther? And I think there's a use for both. It goes slightly past 3 times its original length. I notice 1 equals 3. I get what you mean. Could we explain it to someone younger than us? So, all right, keep going for a couple minutes, then we're going to take some notes together. If you feel like you're farther along than other people and you want to start your notes, I will show you in a moment kind of my... So actually, I'm going to tell you now so that you can take a moment to do this just as you decide to stop on the computer for a second. When you go to trace a circle on your paper, which honestly, if I was you, I would just like title this circles. Yeah, all my markers are over there, so I guess I'm just going to use a pen. So on our notes page for today, but when we go to trace a circle, guys, what I would try to make happen is that these little tick marks, if we can try to line all of them up on lines. See how I'm kind of all lined up on like lines here? My tick marks, not the diagonal tick marks, but my vertical tick marks and horizontal tick marks. If I can try to line those up on lines, it will help me as we start to talk about this. Because then I could actually draw this line across. So as you have a moment, radius, circle. It's F-E-R, by the way, if you were the person that had misspelled that. Totally fine. This is not a spelling test. Dang it, I got too excited to spell circumference. We're also talking about diameter. this tape, love that my measuring tapes also work in centimeters. This table is 180 centimeters long. So there's one number to think about, 180 centimeters long. My circle that I have here is 50 centimeters wide. So if we give this circle a starting point, by the way, here's our vocab if we want to start labeling our notes. If you go across the center, what do we call that? Yeah, you might be able to read from back there. You might not be able to. It's the diameter. So we could label this D. And then off to the side, we could say, hey, D is our diameter. Hey, guys, I'm hoping that I don't have to pause you to take these notes, but I'm going to walk around and check that we have these notes written down. So if you're not writing down these notes, pick up a pencil and start doing it. Anyone know what we call it if I don't go all the way across, but I start in the middle and just go out? Zane? So the R is radius. And then everyone always talks about this word circumference. And we learned in our root word study, what does circum mean? Around. So the circumference, if you want to label it, we could actually say, okay, the circumference. So circum for F-E-R, not U-R, F-E-R, ence, E-N-C-E, because ence is often meaning like distance, and that's all the way around. However you want to draw that so in your head you can remember, yeah, that's all the way around. Circumference. Now, so we're saying it's about 3 times as much. Okay, so if this is 50 centimeters wide, if I start, let's say the radius is my start point, that little blue arrow, and my table we said is 180, can I make a full rotation up here? Will I be able to make a full rotation? How far? Turn to a neighbor. If this is 50 centimeters wide, how far should it go approximately? Chat for like 10 seconds. How far should this go if it's 50 centimeters in diameter? When I spin it once, how far is it going to go? Zeke, you're going to need to help me. When I finish this, you're going to need to be able to tell people how far I went. Do you think you can do that? Yes. This measures the... All right, so hopefully you and your partner made an estimate. What do you guys think? 150? Like exactly?
Maybe like a little bit more.
A little bit more, he says. What do we say over here? 150? Around? More or less around? Okay, we're feeling more. So if we rotate this. See how far we go. The blue, so the bottom numbers. See, what are we close to? We're actually pretty darn close to 160. And here's why. Sit down, because we need to write more notes. Oh, this is pulling through already. I did not want you to do that. Sorry, I try to make little classroom manipulatives to help show things, because not everything has to be computer. The circumference is, okay, so we said approximately, let's do a squiggly equals 3 times the diameter. But guys, I have a little secret to tell you. And you might know this if you've worked in the kitchen at all. What is the crust? If you think about, like, at the holidays, and you go in the kitchen, someone's making a crust. What's that for? What is it, Zane? Pie what? What's the crust? It's pie. It's not the whole pie. It's the pie. You're not remembering my little joke I made? I think I've told it to you before. Crust is...
Diameter?
No. Crust is pie dough. Because crust... No, for real. Crust is pie dough. Crust is the dough of the pie. But in math, what we want to remember actually is that circumference, the C, circumference. You can remember this as crust because like the crust of your pie that you'd be able to see, crust is pi, the mathematical pi. So that would actually just be the pi, right? Pi, and instead of dough, what do you think I'm replacing that with? The D for diameter. So if our diameter is 50, so like the circle that I had up there, right? If the diameter is 50, I want you to turn to a neighbor and calculate what is, well, wait, what the heck is pi? We just celebrated what the heck pi is. It's 3.1415925. Guys, do you guys know how many decimal places of pi NASA uses?
It's like 14.
14 or 50, depending on what they're doing. The most. So guys, we don't need to use a ton of decimals of pi, but here's the trick. On your calculator, which you might need to come borrow one from me so you make sure I give it back, there's a pi button right here. That puts in as accurate of pi as you can. Or we just use 3.14. So you can either do 50 times 3.14, or we can do 50 times the pi button. But go ahead and calculate. What do we get? When we do 50 times 3.14, or 50 times the pi button, what do we get? And if you're a calculator, hey, everybody needs to pay attention in this moment. On the test next week, when you have a calculator, you will have a computer calculator available. But if you're using one of these, which I don't have enough for everybody, so y'all better start bringing your calculators back to school if you want a handheld. If you're getting an answer like 50 pi, hit mode, go down to classic, and mode is right here at the top. Right, go down to classic, select it. Now when I do 50 pi, it'll give me the classic answer of a decimal. But this comes out to be, if I try to calculate circumference, it's 3.14. And on our notes, we might as well write this down to make sure we have this to reference, times the diameter of 50. And it actually comes out to be 157-ish. But guys, so you can't just tell yourself, oh, it's 3. It's more than 3 times, right? It is over 3 times the diameter, because it's actually 3.14, and that 0.14 can't really be ignored, but if you're trying to approximate, it's about 3 times as far. Emery?
Like, can you just elaborate more on what pi? Like, I just don't understand. Like, is it? I always
Yeah.
think it's like some infinite circle or something.
So this was exactly, you're stealing my lesson, which is good, because it's saying that you're anticipating where I'm going.
How do you do the mode thing with the calculator?
Hit mode, this button right here, and then scroll down to classic, and click enter. Here's where pi came from. It goes a lot deeper than this, but I'm going to give you the quick overview. If you had a round object, imagine perfectly round, and you rolled it across the ground until it stopped where like you had started, right? So I start on my radius arrow, start there, roll it till it stops. And you take that distance, the distance we rolled, and you divide it by how long it is from edge to edge. That literally, and if you want to write this down, because no one really taught this to me until, I don't know, they just said memorize this. But where pi comes from is literally the circumference divided by the diameter. If you try to do this division, it will keep long dividing forever. Forever. Still going. It's been going for years and years and years. There are supercomputers still calculating decimals of pi. There are more decimals of pi now than there were when we started class. Seriously. They're still computing that division. And that is one of the special features of a circle being essentially, like, how many sides does a circle have? Is it one? Or is it infinity? Is this one side around here? Or can we think of this as an infinitely many-sided, like, think of an octagon, right? Now think of a 20-sided gon. A dodecagon, I think, I forget. I get all the prefixes mixed up. Now think of a 100-sided gon. It's starting to look more like a circle, right? Now think of a 1,000-sided gon. Yeah, a little weird. And tomorrow we will look at, what if I broke my circle into slices to kind of look at it more like a polygon? So does this have one side, or does it have infinitely many sides? But that's kind of how pi happens. Emery?
So, for pi, it doesn't matter what the diameter is?
What do you mean? For pi, I mean, to get, if you're trying to find pi, yes, diameter definitely matters. So pi is a mathematical constant.
I know, but like, you said that like, pi is like the circle.
The distance around.
Yeah, it's a circle. You understand. So, does that mean it doesn't matter, like, what the diameter is, that pi is still the same?
No, it 100% matters what the diameter is. What you would be doing if you are trying to calculate pi is you would take the distance around the circle and divide it by the distance across the circle, which is the diameter. So please don't try to tell yourself the diameter wouldn't matter. To get pi, right, if we were trying to find it, and that would come out to be approximately 3.14. The main thing we need to know is if we are looking to find the circumference, that it can be found by doing pi times the diameter, because we know this work is true. The Pythagoreans and a bunch of Greek people proved this for us. And because of this, we can say this, that circumference is pi times diameter. And how you can remember that is crust is pi dough. Whatever the diameter of that circle.
Yeah, I know.
So you'd have to pick a circle.
I know. What circle did they pick?
I don't know. Any circle. Any circle you do this with, you will get pi.
I know,
but it has to be perfect, Emery, and your measurements have to be perfect. So computers are doing this. It's not an actual person. We can't measure the perfect distance around this circle. We just can't. We're humans, there's error. I can't even measure the perfect distance across. I tried really hard to make this a 50 centimeter circle. Do you think I got exactly 50 centimeters? No, I'm a human. So, like, quit getting stuck on the nitty gritty. Computers are doing this, but if you manually did it, so Emery, like for real, if you manually measured this and you divided it by the distance, you'd get 3.14. It's, would you get 3.14, 1, 5, 9, 2, like, would you keep getting the right decimals as you keep dividing? Probably not, because we're humans. The computers are looking at perfect circles with perfect measurements. And it can model that, right? Like a computer, you tell it, model me a circle, and it models. And then you can say, measure me this distance, and it measures. Like, computers can do things pretty much exactly. All right, so unpausing this. Let's all go to slide 7. Yoink. Haha. let's look at slide 7 together and see if you can figure it out. Turn to a partner if you need help thinking about this. They show us the diameter, right? They're showing us the width of the circle. Am I just going to go that far when I roll? No, because we just talked about how far we go. Turn to a partner if you need to. How far should we go? Get a calculator if you need. So, Bethany, how could I figure out how far this circle that is 4 across, how far that would go? I couldn't barely hear you, but I think so. Try it again. Yeah, we're looking for the circumference, because that's how far it goes in one rotation. So, Bethany said take that 4 and multiply it by pi. So what do we get if we do 4 times pi? It's going to be more than 12, right? Because we said it's more than 3. 12 point what? Sorry, I need to turn my air purifier thing down. So if we do pi times 4, boom. You have the last 8 minutes to work on Khan Academy. Check again because I posted new things today. Yes. So, with that, before we check progress, our winners from last week. That now we also have a wristwatch calculator in the prize bin if you so choose.
What?
Yeah, I know. Somebody gave it to me, one of my friends. They're like, here, give this to a student or something. And I was like, yeah, sure, or something. And I've been, trying to figure out what to do with it. So we actually have 3 winners from this class because there was a tie. What there wasn't a tie on was that Bethany took home the largest amount of time invested last week with 283 minutes. That's like 4 hours, friends. Like 4.5, actually. So very good work, Bethany. Come on up and get something, either a prize, candy, whatever. Jane and Donna were leading our class in leveling up. Both of them, come on up, leveled up on 17 skills. Guys, that's almost a whole ring on their own. That's almost a whole ring on their own.
Didn't Tommy do like 70 skills?
Not quite.
I thought he said.
I mean, yeah, but some of them didn't quite count because they were doing skills in other classes. Like, I had to clarify with them what counts and what doesn't. And by a narrow 35 percentage points, right? This is why I had to come over here. I can't keep all this stuff in my head. By a narrow 35 percentage points, we won last week. So once they choose their prizes, everybody can come up and get a piece of candy.
Yay, we won!
After.
Sam, after.
But if you want to keep leading, you could maybe be doing some Khan Academy since we have 5 minutes left right now. And then we will check our progress in just a moment. Pick up prize and sit down. Yeah, if you want one of those notebook journal things, I like how those feel. My friend used to work for apartments.com, so that's why I have random apartments.com stuff. Yeah, so everyone, if you want to come up and grab a piece of candy, I think they already did. Do it in, like, a reasonable fashion, or I will stop doing this. Like, if you're fighting with each other or whatever, like, nah. Or I can just buy all the exact same candy. Then there would be no arguments. Yeah, I had some granola bars, and I tossed those in there for in case my anti-candy people. All right, let's see where we're at this week. Huh? You're good. I know you were probably finishing. Yeah, our class won. All right, I don't know where they are now.
Who's them?
3A, because this is where they were as of Friday. My advisory can attest to the fact that we checked this all together at the same time in advisory. So we did this fair. This is how you guys won, because we checked during advisory and we were up by 35%. So obviously we're quote unquote winning right now, but I don't know what'll happen after 3A checks their progress. I'll get that up on the door once I can. But question is, how much work did you do over the weekend? How much progress do you think we'll make here? All right, here we go. Do you think we'll fill ring 4?
Yeah. Oh my god. We better. I took like 2 hours.
Do you guys think we'll make it to ring 6? This is what I really want to know.
Not on this one.
All right, so the accelerated math classes are in ring 6. I want to know if we can get past them. I think some of us did a lot of work over the weekend.
Whoa, past Tommy.
What? Ah! It did it on its own! Every now and then it glitches. We made it. We're 65% into ring 6. Hey, question is, could we fill this by the end of class? You got like 3 or 4 more minutes.
Can you get another piece for beating accelerated?
No, because it's not even a competition between y'all, and they have not checked their progress yet today.
I'm grinding.
I will, though, make a new little sign for the door so y'all can brag to the other Math 7 class.
Yeah.
Be like, 1B. Guys, so you're at 65% of ring 6. Emery, open the door real quick. Because it's more fun to check the thing I put work into making. How far were the other classes?
1B is 6. Is at like
3. We're trying to 3B.
like 6, 38%. So they're like at ring 6, 38%.
So 65% for 3B. 38%. Like, so yeah, I think you guys are just winning overall right now.
We're trying to 3B.
3A, well, they're still from last week, and I hope it doesn't accidentally update on its own. Yeah, see, theirs is still from last week. So some of them did work over the weekend, too. Sorry, guys. Occasionally, like, if I've zoomed, see how my zoom is different? I don't know why, but occasionally when my zoom is weird, it just checks the progress all on its own. So, like, we are here now.
Just level up, guys. Look at us, bro. Wait, when does this cost end?
One more.
In, like, 1 more minute, yeah.
Can we check again?
Yeah, we'll check in a moment. I'm going to start writing your card, though. And guys, remember, there is a potential of both classes, like you and 3A, being able to earn the movie if you guys are real close. Or, of course, if you're winning, you get it. Like, but it's like there doesn't have to only be one winner if we've all put in really good effort. All right, you want to check one more time? Ooh, ring 6, 75. What? Where's... It keeps happening. It just keeps going. All right, get out of here, friends. You're at 80% of ring 6. Great work.
Hey,
We're so built different.
Okay.
I gotta add some exclamation points.
Let's go.
Be jealous.
I mean, so am I. I have 40 already.
I just did 2 of those assignments in whatever that amount of time that we had was.
It's amazing how we can get work done when we decide to do it. I'm proud of you, Zane. Nice work.
Nice. Okay, so
What?
how do I find the diameter by knowing the circumference?
Well, if you know this formula, and you could plug in circumference right here, how could we get rid of pi being multiplied?
Could I just divide, like, could I divide?
You divide by pi. Yeah. and then that'll get us the diameter. But then the radius is half the diameter.
I think I got us like the extra 5% because like I just turned it in
Yeah.
while the other thing was going up, and then you checked it again.
Nice. Goodbye. Have a great day, guys.